I'm Robin Dry from Chadwick Clarke. We're architects based in Cambridge. I'm representing the project team who designed the rising path here at Botanic Gardens, Cambridge University. The structural engineers were Smith and Warwick. The client was Cambridge University and Cambridge University Botanic Gardens. The M&E engineers were Max Fordhams. The main contractor was Milcam, and they did a very good job, and we've been working on this project for 3 years now. The project started from the University and Botanic Gardens applying for some grant funding to work on the systematic beds here at the Botanic Gardens. That money involved a certain percentage for a statutory, and a competition was held. We entered that and were very fortunate to get shortlisted and eventually win it with what is the winning scheme we're looking at now. The rising path takes a very delicate approach to creating a structure in what is a very historic landscape. We spent a lot of time talking to the client, talking and understanding the needs and the sensitivity and how we can respond to that. Systematic beds originate from the 19th century. The majority of botanic gardens at the time were producing gardens which were linear, which reflected the book and the way the plants were organised. Cambridge University came up with a novel and unique way which actually grouped together plants and their relationships between the beds, the planted beds. This was unique and this needed to be celebrated. Over the years, DNA have actually discovered that some of the original concepts and the original ideas and relationships was inaccurate. This part of the process was to understand that and to map it and to do some modifications. And the understanding of the systematic beds was integral to this project. The strategy for us was to create a structure which got you elevated. Cambridge is very flat and the Botanic Gardens has very few elevated positions. The systematic beds really needed to be read from an elevated view so you can understand them. So this whole structure allows visitors to the Botanic Gardens to read the systematic beds and understand them. And getting elevated is the important element. The path takes you on a journey. As you approach systematic beds, you then walk through them and you approach the structure. You get elevated by following the path up. It's 60 metres long and you get 2.8 metres high. That structure is a galvanized steel curved truss, effectively, which is made of 10mm galvanized steel plates, which are curved and spot welded to a curved former, and they have steel columns which are offset, creating a diagonal grid. So the original concept was for a circular structure, so it's a circular rise, spiralling structure. When we started looking more closely at the site, what we found was we had several plants and trees in a position where we needed to manoeuvre the structure and manipulate it away from from a pure circle. We also found that there was the university's primary data connection to Addenbrooke's Hospital and close by, so we had to, that influenced the shape. So what started off as a circle became more of an irregular ellipse. That came with itself with a whole range of challenges because there was every single curved element was a different radius and had a different form of geometry. We also wanted to make sure that the rising path sat delicately in the landscape, and one of those elements was to avoid a heavy series of columns as it touched the ground. Working with a structural engineer, we came up with a strategy which created offset columns, which allowed the structure to sit delicately, and it also came with a dual benefit of creating a truss, a triangular structure, which was a series of flat planes which twist as you go up the rising path. That allowed the timber to sit without having to curve, and it meant that all the gaps between the timber were regular. There's only two materials on the structure. There's a coir, which goes for the balustrades and for the decking itself, and steel. The steel structure is exposed, it's galvanized, and it's a raw material, and it's 12 months old now, and it's dulling down and looking very lovely. Behind the coir you've got the steel plates. One of the characteristics of a coir is you need to separate that from galvanized steel. So there's a spacer plate, which means that the timber doesn't stain, but more importantly there's no chemical reaction between the coir and the galvanized steel. A coir for us was a really important choice because of its longevity, but also the fact that when it's machined it's a very smooth surface and it's a very regular surface without any knots and irregularities. The decking was a challenge. We had a client who, once we'd got it established in the pinetum to one side of the systematic beds. They wanted to bring in additional information and additional experience for the visitors to the Botanic Gardens, and we spent a lot of time looking at how we can integrate graphics and information into the decking. And what you see today is quite unique collaboration between ourselves and Gripsure, who are the decking manufacturers, in creating text which were hand applied into the routed out timber. The steel structure was an obvious starting point for us. We wanted slender lines, we wanted it to be delicate, and we wanted it to sit harmoniously with the spiralling curve. Each column sits on a galvanized plate, so the entire structure, all the way down to the foundations, is galvanized steel. For us, this was great. This was fast. It was economical. It also means that in such a sensitive site, we can remove any of the components in 20 years' time and actually leave minimum scarring in what is an historic location. The steel structure and the geometry started out for us as a BIM model. So we were working in ArchiCAD, and we worked extensively three-dimensionally from the outset. The structural engineers also worked in BIM, and working between ourselves, we refined the steel structure. It also meant that we could reduce the number of components, and using laser cut steel plates, curved, and the processing, we were able to transfer our information to the steel fabricator, who in themselves created a BIM model. But it was really important that the steel fabricator created their own BIM model, and they modelled every single connection, which was unique, I think, for the top of every single column. Each radius was calculated and then fabricated and brought to site. And I think out of all the components, I think we ended up sending one piece back, which for a project as complex as this was incredible. One of the other bits which is difficult to understand was the subtleties to the whole structure. You walk around and there's only a very small number of components on this building, so you end up having to work to very tight tolerances. The fabricator had to pre-drill the stringers for each balustrade before they curved it, and they had to allow for the curving and the setting out. So when the timber arrives and is set out, you've got a regular spacing between the timber balusters. That's a high level of precision, which only could be done with BIM. But also we were very relieved, I think, at the end of the process, because it's something which could have been very difficult. And all credit to the fabricator; they did a very good job. I think the rising path really shows the potential of galvanized steel. What we have some very specific components which were designed, modelled, prefabricated, drilled, galvanized, and then brought to site and assembled in a way that actually had worked to tolerances which, quite frankly, wouldn't have been allowed, many years ago wouldn't be possible. Here was a finish item which not only looked beautiful, but actually was really well engineered. And for us, it could only have been galvanized steel. The rising path needed to have as minimum amount of maintenance as possible. So selecting a galvanized steel finish for the structure allowed the university to have effectively zero maintenance for this, for the steel frame. The selection of the materials and the way they aged and the way they picked up a patina was important to us. The Akoya starts off as very bright, almost kind of cream yellow colour as a pine, and that will dull down to a silver. The galvanised steel, when it arrived, was highly polished and finished, and that was the natural finish coming out of the vat. Over time, and in the first 12 months since it's been installed, it's dulled down, and I think both these materials will together age and have a natural patina which for the setting is just beautiful.